Welcome to video lecture on microprocessors. Course code is W2110. This is second video tutorial. In last tutorial, lecture 1, I have discussed about basics of microprocessor, basics of its assembly language, machine language, how the machine language was formed and how assembly language was formed. And after that, I had discussed about 8085 microprocessor, a pin diagram of 8085, its internal architecture of 8085. Now it is time to move to the microcontrollers. Let's begin with the definition of a microcontroller. A microcontroller is similar to the microprocessor in almost all the functionalities, and that is made to read the data, perform limited calculations on the data and control its environment based on those calculations. Okay, it has the features like microprocessor, all the features of a microprocessor like ALU, program counter, stack pointer and all. Okay, and in addition to all the features of a microprocessor, it has an internal RAM, it has internal ROM, it has certain IO ports to interface with the IO sectional world. It has timers and counters. In addition to that, it may have analog to digital and digital to analog converter also. All these facilities will be there on a single chip in addition to the features of a microprocessor. This is a typical generic block diagram of a microcontroller. You have timer, counter, program counter, IO ports, interrupts and clock, internal ROM, a stack pointer, internal RAM and accumulator and some working registers. And inside we have say ALU, it is arithmetical and logical unit. Next, coming to let us be very specific with the microcontroller of 8051. 8051 is Intel MCS 51, commonly termed as 8051. It is a single chip microcontroller MCU series developed by Intel in 1980s, and the development mainly was for usage in embedded systems. Let's focus on the features of 8051. 8051 is basically 8-bit CPU. It is a 8-bit wide microcontroller. That means it can process 8-bit of a data at a time on a single clock. That is why it is termed as 8051. Then it has some working registers which are of again 8-bit wide. They are accumulator, A register, B register, stack pointer ESP, program status word PSW. These again 4 registers are of 8-bit wide. Now, there are 16-bit registers also which are possible in 8051. They are program counter, DPTR and timers. There are 2 timers which are of again 16-bit wide, T0 and T1. Okay, then in addition to this we have 4 kilobytes of internal ROM. These are all again on a single IC, single chip. So 4 kilobyte of internal ROM. The basic necessity of having this internal ROM is same as we have a hard disk for our personal computer, where we will be installing or storing operating system and some applications. Similarly, when you want to write some applications for 8051, we have to write those applications, download those applications or burn those applications into the internal ROM of 8051. So the size of internal ROM is somewhere around 4 kilobytes. That means is we can write an application, a program of 4 kilobyte wide that can be accommodated inside a 8051 single IC. Then in addition to have a permanent storage, we have certain temporary storage also, like we have internal RAM of 128 byte. Okay, the same IC we have even temporary storage, that is random access memory, as 128 byte. This 128 byte is arranged as banks. There are 4 register banks. Around 32 bytes is arranged as, is dedicated as and named as 4 register banks. They are named as B0 to B3, and above that we have 16 bytes of a memory as bit addressable memory, right? And after that we have 80 bytes as a general purpose memory. Then in addition to have RAM and ROM, it has some interrupt facilities also. These are the facilities by which we will be interrupting or dragging the attention of a microcontroller from its regular routine, and we take the control to the specified locations or specified services. So there are 5 ways of dragging the attention of 8051 microcontroller. 3 are from internal and 2 are from external side. So using external stimuli, 2 external stimuli, we will be able to interrupt 8051 microcontroller. And similarly, we have a serial communication facility also, that through TX and RX. There are full duplex serial data links available, this TX and RX. Okay. In addition to these, we have ports. 8051 has 4 ports, and each port is of 8-bit wide. Meaning of saying 8-bit wide is each port is having 8 pins. They are named as P0 to P3. Right. And we have some control registers also, like TCON timer control, TMOD timer mode, SCON serial control, ECON power control, IP interrupt priority, and interrupt enable. So these are called as special function register. Little later I will be discussing about what SFRs are. Then we have an oscillator and a clock circuit also. Now this 8051 is basically based on a Harvard architecture. There is a difference between the Harvard architecture and similar to this we have a von Neumann architecture. These Harvard architecture and a von Neumann architecture are basically based on how the data and the program and application are stored in the memory. If the application and the data related to that application has a separate memory, then we call that particular structure to be a Harvard architecture. Hence 8051 has a Harvard architecture. Okay. So 8051 has a separate memory for a data as well as a program or an application. Let's look at the internal architecture of 8051. It has a facility. If you go from left side, is INT0, INT1. These are 2 external interrupts available through which we will be interrupting a microcontroller. Then we have 3 internal interrupts through which we will be interrupting again a 8051 microcontroller. The other part of this, we can connect crystal oscillator. Inside we have oscillator circuit and a timing circuit. Right. When you go here, it is 128 bytes of RAM. It is used mainly for a data in temporary data storage. It is 128 bytes of RAM. Beside this, we have 4 kilobytes of RAM. Generally, in this we will be writing codes. And here we have timers T0 to T1. Say these are all again 16-bit wide. These are all again on the same IC. Then we have serial port TXD and RXD. TX line for transmitting data and RX line is for receiving data. Transmitting data from microcontroller to the external world and receiving data from external world to the microcontroller through RXD line. Then we have 4 ports. They are all bidirectional. Port 0, port 1, port 2, port 3. Each port is of 8-bit wide. That means for each port we will be having 8 pins. Okay. Then there is a facility here. Assuming that your application size is exceeding more than 4 kilobyte, probably say 5 kilobyte. So in that case, what can be done is we can extend, we can add some more external memory to this IC. It is possible to extend, it is possible to add external memory, either maybe a RAM or maybe a ROM, depending upon our requirement. Here the maximum facility or maximum limit that is given by 8051 is you can interface 64 kilobytes of external memory to 8051, right? And these will be facilitated with ALE, address latch enable, power as a program store enable. So using these pins we will be able to extend its a RAM facility. Okay, let's look at the internal details of a RAM. Right. So here basic thing to understand is the internal division of a RAM. Okay. So internal RAM of 8051 is 128 byte. It will be from this side we have addresses, this side we have details of what RAM, and this is how the memory is being divided. Okay. So this side RAM addresses 0008 to up to 7F. This comprises of 128 byte of RAM. Okay. After 7F, that is 80 to FF, it is also possible to have a memory. These addresses, like in total, since 8051 is 8-bit microcontroller, 2 to the power of 8, that means it is 256 of memory locations are possible with 8051. Okay, but only 00 to 128 or 127, that is in 128 bytes of memory only is being used, and from addresses from 80 to FF all the addresses, all the possible addresses are not used, but very few addresses which are possible they are used, and they are called as SFRs. This will be discussed little later. Let's concentrate on internal 128 byte RAM division. Okay, look at the starting address 0008. At a 00 we have bank 0, then 08 we have bank 1, 10 bank 2, bank 3, and so on. So bank 0, first bank, second bank, third bank, and a fourth bank. And each bank, if you see here, these are 0, R1 and up to R7. Each bank has 8 registers, and each register is of 8-bit weight. R0 is 8-bit weight, R1 is 8-bit weight, R2 and so on, or each registers are of 8-bit weight. Similarly, bank 1 also has 8 registers, R0 to R7. Then bank 2 also has 8 registers, R0 to R7. Similarly, bank 3 also has registers, R0 to R7. Right. These are all general purpose registers. An application developer or a programmer can use all these registers to store their value or temporary storage also. They are available for the users. Right. Now, the upper part of the banks is 20 to 2F. It is bit addressable memory. These locations are bit addressable. So, around 16 byte. This is 1 byte, 2 byte, these are 8 byte, and this another 8 byte. We have 16 bytes as bit addressable memory. There is a bit concept about bit addressable memory and byte addressable memory. Say byte addressable memory, say for example, if I want to access some register in bank 0, say R7, when you say R7 register, complete R7 register we will be accessing. That way of accessing memory locations we call to be byte addressing. Whereas, for example, if I want to access only the third bit of R7 register or fifth bit of R7 register, since R7 register is 8-bit wide, we should be able to access a single bit of these registers. Okay, but here we don't have such facility. Whereas 8051 facilitate this bit addressable concept from 20 to 2F. Okay. So these are the bit addressable locations. These are very helpful when you are developing applications for embedded systems. Right. There, say for example, if you want to interface 8 or say 7 IO devices, just look at the say it is a fan. Just you want to check the status of the fan, whether it is on or off. Just to see the status of a fan, whether it is on or off, we need only one bit of information. Saying, say if it is 0, it's off. If it is 1, it's on. Assume that there are 7 to 8 fans condition need to be monitored. Status of the fans need to be monitored. Then what generally happen in regular programming? Each register may be dedicated for one fan. Then each register is capable of showing its status. Then in that case, what happens? One R0 to R7 dedicated for 8 fans. Then it will be around 8 byte. 8 byte memory will be wasted. Whereas the same thing can be achieved using a single byte. This first bit represents the first fan, second bit for second fan, and so on. So in order to save the memory, then we will have a bit addressable concept. So in 8051 we have around 16 bytes of memory which can be accessed as a bit, not as a byte. It is possible to access as a byte also, but it is possible even to access as a bit. There are few few special purpose registers, SFRs, which are again bit addressable also. Later that will be discussed. Okay. Then upper part of this 2F, that is 30 to 7F, we have general purpose area. This is again 80 bytes. So 30 to 7F is a called as general RAM. Okay. And this can be used for stack, this can be used for some temporary storage also. Then above that, this area we call to be special function registers. Not all the locations possible between 80 to FF will be used for special function registers. Few locations will be used for special function registers. That will be seen in the next slide. See, this is again the details of internal RAM again. This side you see the addresses, right? And here the default bank is 0. Then above this we have bank 1, we have bank 2, bank 3. These are the bit addressable. locations. So 20 to 2F are bit addressable memory. Here a single bit, this bit can be accessed separately, this bit can be accessed separately, this bit can be accessed separately. Similarly, when it comes to the register bank, you have seen here, see R0 to R7, R0 to R7, all the labeling of these registers are similar. You don't have any distinction. The bank 0, this R0 to R7, bank 1, R0 to R7, and bank 3, R0 to R7, but internally they have different addresses, right? These are the registers. R0 to R7 is 00 to 07, R0 to R0F, it is bank 2 register, likewise. Okay. Now, for example, if you want to move a data in R3 register of bank 2, then how do you do it? Right. So if you look at here, I want to store some data into this register of bank 2, right? Okay. Then this selection will be possible based on a special register called as PSW, program status word. We have 1, 2, 3, 4. Fourth and fifth bit of PSW are dedicated for selecting the banks, or RS0, RS1. If it is RS0, RS1, it is based on 00011011 is bank 0, default bank is bank 0, and if it is 01, it will be bank 1, 10 bank 2, 11 bank 3. So for example, if you want to move into third register or R3 register of bank 2, then I should make a selection, then I should update program status word before executing that instruction. So this is how we will be making a distinction between different registers. Okay. Now coming to the upper part of internal RAM 128 byte, you see 80 to FF. This is again 128 byte locations. In 128 byte location, these locations, all the locations will not have any functionality except few SFRs. We call to be special function register. At 80 we have port 0, right? And this then at 88 we have timer control, timer mode, stack pointer, DPL, DPH, data pointer low, data pointer high, likewise B register, accumulator, PSW, instruction pointer, P3, and then interrupt enable. These are all special function registers which occupy their dedicated locations here. Then other locations are unused. Hence, upper part of 8051 internal RAM, that is 128 byte, above upper part of 128 byte is SFR area. Okay. Then let's come to, these are SFR. Upper 128 byte of the RAM, that is from 80 to FF, is allocated for a special function register. SFRs control the specific functions of 8051 microcontroller, like SFR name, accumulator, ACC, accumulator, B register, PSW, program status word, SP, stack pointer, DPTR, DPL and DPH, data pointer register low, data pointer register high. Similarly, P0, P1, P2, P3. See, these are the registers, SFRs. They are connected to the port 0, port 1, port 2, port 3. These are the ports which will be having 8 pins, and these 8 pins internally are connected to this P0 register. You can call them as a buffer, and through these registers, application user or a programmer will be accessing the P0, P1, P2 and P3. Then we have another register called as interrupt priority, IP, then interrupt enable, IE. We have timer mode, timer and counter mode, timer and counter control. We have serial control, serial buffer, like you want to have a serial communication between peripheral world to 8051, and we'll be making use of these control registers. Then if you want to have a timer or want to make use of counters, then we'll be making use of these two SFRs to control the operation of timer and a counter. Similarly, serial buffer to take a data from outside world to a microcontroller, or from microcontroller to a outside world. Then we have PCON, power control. Similarly, TH is 0, timer or a counter 0 high, These are again SFRs. TL0 timer counter low, timer counter high, timer counter low. Right? These are the SFRs of 8051. Okay. Now let's look at the pin diagram of 8051. Here 8051 is a 40 pin DIP IC. It is DIP dual inline package. It has 40 pins. Pin number 1 to pin number 20 left side, pin number 21 to pin number 40 the right side. Okay, let's look at the functionalities. Pin number 1 to pin number 8 are called as port 1. Okay, each pin here called to be P1.0. This is the first pin, that is pin number 1 of 8051 is P1.0, that is first pin of port 1, second pin of port 2, third pin, and so on. This is port 1. It is not having any additional functionality. It is having a single functionality just to have say interface with the outside world. Okay, inside this pin these are connected to a P0 register, that is SFR. Here there will be a SFR register. The ninth pin is a reset pin. This is very important pin, reset pin. Later I will show you the circuit of this also. Then from pin number 10 to pin number 9, pin number 17, these are termed as port 3 register, port 3. Okay, then pin number 10 is the first pin of port 3, 11 for second pin of port 3, and so on. In addition to act these pin as a port, it has dual functionality like RxD, TxD, receive data, transmit data on this. To have a full duplex serial communication, we may make use of pin number 10 and pin number 11 for connecting to the external world through serial mode, that to full duplex communication. Then said about the external interrupts can be connected to these two pins, that is 12th and 13th pin of 8051, INT0 and INT1. Similarly, timer T0 and T1, these are write and read. If you want to write into external memory or read from external memory, we will be making use of these lines. Okay, so this pin number 10 to pin number 17 have a dual functionalities. First case that may be used as a port, and the second case it may be used as these say bracketed functions. Okay. Then pin number 18 and 19 is here we will be connecting our crystal oscillator. Then pin number 20 is a ground. Then pin number 21 to 28, these are termed as port 2. This port 2 register has a dual function called as A8 to A15 is address lines. They can be used as a port pins and can be used as address pins. Similar to this port, pin number 32 to 39 called as port 0. It has a dual functionality AD0 to AD7. Okay. In addition to act as port 0, these pins will be acting as address and data lines, time multiplex address and data lines also. So in combination with the port 0 and port 2, it is possible to have address and data lines, AD0 to AD7 data lines, or A0 to A7, A8 to A15 as address lines. In addition to that, we have, if at all we are interfacing external memory, these are the pins we will be making use of for enabling and disabling external ICs. Okay, so 20th pin is program store enable, this address latch enable, then external enable. Okay, so generally this will be connected to VCC here. And the 40th pin is a power supply, a plus 5 volt power supply will be given to this IC. Okay, so let us, these are the details of pins of 8051. I said about 8051 is a 40 pin DIP dual inline package. 40th pin is VCC, usually plus 5 volt. So whatever I have discussed, I have mentioned here. You can go through. Then let's concentrate. Yes, this is a very important circuit plus a reset circuit. Reset circuit of 8051. The necessity of reset circuit is, say for example, in most of the cases 8051 is generally used in independent system, that could be an embedded system. When it is independent, very less human intervention will be there. I'll just give an example of if something goes wrong with your personal computer or laptop, what generally we do, we generally go for restarting a machine. When you say restarting a machine, then if it is hanging up somewhere in between, then we are telling an operating system or telling a machine that okay, stop here and start from the beginning. Okay, that's very important. Okay. Whereas in 8051 generally we have very less human intervention when it is used in some applications. So there this reset circuit concept is very important. Take an example, assume you are moving into an elevator, probably say third floor, ground floor to fifth floor, say. In between somewhere in third floor, between third floor and the second floor, there is some mistake, something has gone wrong. Then what happens? Your complete embedded system which is meant to operate or control that elevator is has hanged up now. So what to do? Then there we should have a facility. If you press some button, you say you have to restart, then just press a restart button, then restart button will take your complete application to start executing from the beginning. So immediately that bus which was stuck up in between second and third floor may go down and start from the ground floor. Okay, that is a simple application. Let's look at here. The same thing is possible with 8051. It's very important whenever you develop any application based on 8051, you should have this facility. Okay, there are two ways of having a reset circuit. One is power on reset, automatic. Whenever you give a power supply, immediately the control goes to a reset value or reset location. From there it starts executing. Another thing is manual reset. This is if I want to reset a circuit, then immediately just press this button, then immediately the circuit, even if it was executing very critical application also, it starts executing again from the beginning. So this circuit ensures a known state in which the device always powers up or starts operating. Okay, this is the reset circuit. When say reset, I said whenever you give power supply here, it start executing from the reset value, reset locations. So what do you mean by reset locations, reset values? So when anyone manufactures a microprocessor or a microcontroller, the internal registers, internal SFRs, all those registers will be decided by the manufacturer to have some reset values, some known values in the beginning. Those are called as reset values. So likewise even 8051 also has some reset value associated with the register, like accumulate. This is PC program counter having 00 value. That means when you give a power supply, then immediately at that time program counter will have a 00 value. The meaning of this is when you give power supply, it is a program counter which is responsible to take the instruction from the ROM and give it to decode unit. So upon giving power supply, program counter is coded with a 00. It is implicit that program counter goes to 00th location in the memory, get the data from that memory, that is generally an opcode, and give it to decoding unit. And decoding unit start executing. That means the first instruction of your application should be located somewhere in this location. So when you reset a circuit, when you reset a product, then it immediately this PC will be loaded with a 00. It means start from the beginning. Then similarly, that is what is an essence of knowing the reset values. Then accumulator has got 00, then B register got 00, program status got 00, then stack pointer here is 0007. Okay, it is the stack pointer is say when your application demands the calling of a subroutine, calling of a function, calling of ISRs, there the present context of particular scenario need to be saved somewhere. So to save these switching information or context switching, then we dedicate some part of memory, internal RAM or ROM as a stack. Okay, when we reserve certain part of memory as a stack, then we need a pointer, we need a register to access the stack. Okay, so it is a stack pointer which will be accessing those locations. Now those locations will be from 0007. So stack pointer will be pointing to this location only. Then similarly DPTR, DPT data pointer register will be pointing to 00. And all RAM locations will be 00. So these are the reset values of the internal working registers of 8051. Okay, coming to the addressing mode. After studying the internal architecture, pin diagram and details of 8051, now it is the time to refer how this 8051 will be accessing the data. That we refer it to be an addressing mode. An addressing mode refers to how we are addressing a given memory location or how we are accessing a particular data. That we call it to be addressing mode. In every microcontroller or a microprocessor, they have their own addressing modes, and these are the addressing modes which will be defining how the data will be moved inside a microprocessor or a microcontroller, or from microcontroller to external memory, or from external memory to a microcontroller. So these are the methods, these are the ways by which data movement will take place, or the other way of saying how we access the memory decides about the addressing modes. Okay. First addressing mode with 8051 is immediate addressing mode. The instruction itself dictates the value, what value will be stored in the memory. So here a typical instruction say move a comma hash 20. This is a typical instruction in which I am giving a data hash 20. This is the data of this instruction is available with the instruction itself. That is why it is called as immediate addressing mode. Okay. Then next is direct addressing mode. The value to be stored in memory is obtained by directly retrieving it from another memory location. We say here the example, move a comma 30h. This 30h is not an operand or a data with respect to this instruction, but it is a memory location where the data is stored. So this instruction goes to 30th location of memory, gets the data and store into accumulator. That is why we call it to be direct addressing mode. In direct addressing mode, we give the address of the data for the movement in the instruction itself. So instruction carries the address here, whereas here instruction carries the data. Data related to this instruction is available in the instruction itself, hence it is called immediate addressing mode, whereas here the data related to this instruction is stored somewhere in the memory, and that memory information is given in the instruction. This is called as a direct addressing mode. Then next we have register addressing mode. In register addressing mode, data is transferred between the registers only. This internal again. So R0 to accumulator, accumulator to R0. If data is moved between the registers, then we call it to be register addressing mode. The fourth one is indirect addressing mode. Here the address of the data is located in some registers. The instruction says here move a comma at R0. That means here the operand, the address of the operand, address of the data is stored in some register R0. We can compare this with this now, direct addressing mode. Here the address of the operand is given in the instruction, whereas here the address of the operand is stored in some register R0, and that register is mentioned here. Since it is very indirect way, so control goes to this register, get the data, that data is the address of the operand, then it goes to that particular location, from there it gets that particular operand and store that into accumulator. Hence this is called as indirect addressing mode. And similarly we have external direct addressing mode. It is possible to have or interface external memory also. When you are interfacing external memory, either RAM or a ROM, then we will be accessing data from the external memory also. Okay, so that accessing got to be external direct addressing. It is used to transfer the data from external memory location into accumulator. The address of the operand is stored in DPTR. Here it is default. The address of, if it is a RAM, then address of that RAM need to be stored into this DPTR register. Okay, so move X, it is external memory. It goes to the memory location whose address is in DPTR, get the data and store into accumulator. So this is an external direct addressing mode. So here immediate addressing mode, direct addressing mode, register addressing mode, indirect addressing mode, and external addressing mode. So these are all about the addressing modes of 8051. Right? Yes. So let I revise what is that we have learned now is microcontroller definition. It is a microcontroller. Microcontroller has all the features of microprocessor. In addition to that, it has a RAM, ROM, IO ports, counters, timers, ADC, DAC on a single IC. And this is 8051. 8051 features. It is 8-bit microcontroller. It has ports, it has RAM, it has ROM, control registers, it has special function registers. It is based on Harvard architecture. This is internal architecture of 8051. This is internal RAM. Internal RAM is 128 byte wide, and that is divided into banks, bit addressable memory and general purpose memory. Then upper part of internal 128 byte RAM is a special function area, so special function registers. Then these are the details of that. If you want to switch between the registers of a different bank, then we have to make use of the RS0 and RS1 bits of PSW. These are the SFRs, the pin diagram of 8051. Except port 1, all the ports will be having dual functionality, and these are the pin descriptions. This is a reset circuit, and these are the reset values. Yeah, these are the addressing modes. Okay, now addressing modes refers how we are addressing a given memory locations. Right, after studying this, we have to study instructions of 8051. So we will be discussing about 8051 instruction in the coming video. Thank you. Thanks for watching. Thanks for listening.